Okay guys, so the previous video talked about recurrence relations, and now we're going to move on to arithmetic series. So if you remember from that first video introducing the difference, arithmetic series is when you have terms plussing or minusing a common difference each time. So examples of which could be 1, and remember this is a series, so plus 3, plus 5, plus 7, and it goes on, okay? This is term number 1, term number 2, term number 3, term number 4, and it's going to go on until term number n. Now half the skill is to find what the nth term is and how we describe these things. So we're going to step away from the stuff you learnt in GCSE, remember? And what we're going to do is we're going to say for an arithmetic series, the nth term formula equals the first term a plus n minus 1 d. So a is the first term, this un is the term itself, n is the term number, and d is the common difference. So let's then put this series that I've put in front of you in terms of an nth term. So un would equal, well, a is the first term and a is 1, plus n minus 1. What's the difference between these? Well, it's plus 2 every time, isn't it? So therefore the common difference is 2. There we go, we've got an nth term. And from here, I could work out, well, find the 100th term. So this little u becomes 100, so u little 100 is the 100th term. It equals 1 plus 100 minus 1 times 2, which equals 1. Remember, I don't have a calculator. Plus 99 times 2, which is 198, plus 1 equals 199. Right? So that's our nth term. And you can see how I got this a plus n minus 1d by writing out again our terms like this. So first term is a, remember, then we're plussing a common difference, which is d, so the second term will be a plus d, then we're plussing d again, a plus 2d, a plus 3d, all the way up to a plus n minus 1d, because here we have n is 4, but we're timesing the common difference by 4 minus 1, which is 3, and if you go along, it's the same. That's the nth term. We do need to absolutely know our formula back to back, okay? We also need to introduce the sum of the formula. So that's the nth term, but what about if we had the sum of the series? So if I added all the terms of a series together, okay, I would have this formula, and we're going to summarize, well, we're going to derive and prove this in a minute, because you may be asked to do that in the exam. And the first version is Sn, so Sn means the sum of the first n terms that you're looking at. So if I was looking at 100, I had s of little 100, equals n over 2 times 2a, so that's 2 times our first term, plus n minus 1 d. The second version, which is exactly the same thing, is n over 2 times a plus l, where L, this is not capital L like in the recurrence relation, is completely separate. L is a small l for a start, and L means the last term. Okay? I'm going to prove to you on the next slide then how we derive those formulae, because they're important. But actually let's use this in front of us. Let's use this. quickly to demonstrate. So let's go back to my original one. Now I want to find the sum of the first 20 terms. So S20 equals, well, n is 20 divided by 2. I'm going to use formula 1 here. My A is 1, isn't it? So 2 times 1 plus, I'm looking for the 20 minus 1, because it's n minus 1, times my common difference D, which is 2. So this is 10 times 2 plus 19 times 2, which is 38, which is 10 times 40, so that's 400. Okay, so if I added the first 20 terms of this series together, I would get 400. So now let's actually prove this then. Prove the formulas. Okay, so I'm going to prove first that Sn equals n over 2 a plus l, because this is the easiest proof, and then you could prove the other one from here because they're the same thing. And how we do this, we're going to write this as, we write the term numbers, always write the same amount of terms either side of this dotted line. So this is the n minus 2th term, n minus 1st term, and the last term n. So remember, first term is always a, and then we have this common difference, a plus d, and then we added the common difference again, a plus 2d, and then let's go backwards this time from L. So the last term is the nth term, so that's the last term, isn't it? But the term before it though, a d has been added to get L, so I need to minus a d for this term before it, so this is L minus d, and the same, this is L minus 2d. Yeah? Now, this is going to seem a bit abstract, but what I'm going to do to prove this is I'm going to write Sn again. And there's lots of ways of proving it, but this is the neatest way. And all I'm going to do is I'm going to flip this over and write it in reverse. So now I'll have L plus L minus D plus L minus 2D dot 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 plus A plus 2D plus A plus D plus A. I haven't done anything to it, all I've done is flipped it round. And it's really, really important that I've got an even number of, well, as in the same amount of terms either side of this dotted line, because this, you know, it makes sense. Now what I'm going to do is I'm going to plus both sides together. So actually I get 2Sn equals, well, A plus L. Plus, well, here I've got A plus D plus L plus minus D, which will give me A plus L. Here I've got A plus 2D plus L minus 2D, which gives me A plus L, dot 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 dot, plus A plus L, plus A plus L, plus A plus L. How many lots of A plus L do I have? Well, from here, I've got n lots of A plus L, which means that Sn, to get Sn by itself, I have n over 2 A plus L. Okay? That's how we prove that formula. And you could be asked to do that in the exam. But let's then prove the second formula, because remember, this is the one I said was number 1. Let's prove the other one. Well, it's easy, because if we look at L, L is the nth term. Yeah? And if it's the nth term, we know that un equals a plus n minus 1 d. So all I have to do is insert L, which is a plus n minus 1 d, which gives me a final answer of Sn equals n over 2 2a plus n minus 1 d. And there's my second formula proven. Let's do a couple of examples then. So, the third term of an arithmetic series is 5. I never overwrite u3 equals 5. I'll always write it in terms of a's and d's. So u3 equals a plus 3 minus 1, because it's n minus 1, d equals 5, which means a plus 2d equals 5. Because most questions are going to require you to use simultaneous equations, so there's no point me excluding a's and d's. The fifth term, so u small 5 equals a plus, I'm not going to write it again, but 5 minus 1d, so 4d equals 9. So I've got two simultaneous equations here, and I've got two unknowns. I need to find a and d. So all I have to do is minus them from each other. The a's disappear, and I'm left with 2d equals 9 minus 5, which is 4. So therefore d equals 2. How do I get a then? Well, sub d equals 2 into any of the equations. I'll pick number 1. So I get a plus 2d, which is 2, equals 5. Therefore a equals 5 minus 4, which equals 1. Done. Question 2. The first term of an arithmetic series is 12, so u1 equals a, which equals minus 12. And the last term, okay, L is the last term, equals 40. If the sum of this series, so again, as I'm reading this, I'm writing this stuff out. So the sum of the series, Sn equals n over 2. Because I've got a's and l's given to me at the start, I reckon I'll stick with this second, well, the first one that I showed you. And the sum of the series equals 196. Find the number of terms and the common difference. Well, okay, so 196 equals n over 2. I've got an a, which is minus 12, and I've got an l, which is 40. Therefore, 196 equals n over 2 times 28. I'm trying to find n, so this gives me 196 divided by 14 equals n, and therefore n equals 14. Okay? Now it says find the number of terms and the common difference. Well, again, what we can do is we can compare this first equation with the second version of Sn, okay? Because the second version includes d's, and I need to find d. So therefore I can say that n over 2 a plus l equals the same as n over 2 2a plus n minus 1 d. Therefore, plug in the numbers. I know that 196 is the sum of the series, don't I? Which is this bit. I know that n is 14, because I've just found that. 14 over 2 times 2. This time a is minus 12 plus 13 times d. Do you see I've got all the ingredients now to find d? So this is 196 equals 7 times minus 24 plus 13d. Let's multiply that out. I get 196 plus 7 times that's 140 plus that is 168 equals 7 times 13. 7 13s is 70, 91d, which gives me what's that, 200. 196 plus 168 is 364. Divide that by 91 to find d, and you get d equals 4. And we're done.